zero exponents and negative exponents, what those are, and then look at simplifying expressions with those. All right. So first thing we need to do is talk about a little bit of terminology. So I have this 5 squared right here, right? You guys can't see that. So I have that 5 squared, right? We know what's the exponent there?
The 2.
The 2, right? We're pretty used to seeing that. Chromebooks away, please. But the other thing we have is that we have what we call the base, right? So whatever is being raised to that power is my base, right? So that's some terminology that we haven't used quite yet, okay? So we're going to use this table here to help us figure out what the rules are for negative exponents and zero exponents. So 10 to the first power is what, John? 10 to the first power is 10. All right? Somebody tell me what 10 squared is. 100. 10 to the third power? 1,000. 10 to the fourth? 10,000. So, what happened every time so 10 to the first, 10 to the second, 10 to the third, what happened with my answers?
0.
I'm kind of adding a 0, right? I'm multiplying by 10, but I'm adding that 0. So, any ideas on what 10 to the 0 power is going to be?
0. Negative 10.
So, if I take away a 0, what am I left with? 1.
Oh, that makes sense.
Okay. So, we're going to move down just a little bit. We're going to go back to those negative exponents in a second. So that 10 to the 0 power being 1, right? That works for every number when I have a 0 power. So anytime I have a number, like a is any number, right, raised to the 0 power, that answer is always going to be 1. All right, so every time it's going to be 1. So if I do 3 to the 0 power, I get 1, right? 1,500 to the 0 power, 1, right? 0 power, hopefully, is the easiest one for you, right? It's always going to be 1.
How is it 1?
Just because it's 1.
Because I mean, that table kind of shows us there's that pattern. No.
How is it 1?
So let's think about any ideas on what 10 to the negative 1 power is going to be?
Negative
0.1.
And then the top one is 0.01.
0.01.
Okay, look at you.
Okay. So I can think about that as kind of moving a decimal place, right? Because that's kind of what I'm doing when I get rid of zeros. I move a decimal place. Yeah, kind of. I'm kind of getting smaller. So let's talk about though. So I have from that table that 10 to the negative 2 power. Deacon, are you good? Logan? Yeah. 10 to the negative 2 power, right, is 0.01. Okay. So let's break that down into something that makes sense with that 10 to the negative 2. So does anybody tell me what that decimal is if I were to say it in words? 0.01. If I were to say that as far as place values, what? 100th, right? So how would I write 100th as a fraction? 1 over 100. And then if I think about 1 over 100, right? Could I write that as 1 over 10 times 10? Yeah. What is 10 times 10 if I want to write it with a base and an exponent?
10 to the second power.
10 to the second power. So now I'm going to look at, right, what's the relationship between those two things? What kind of changed and what's the same? So now I've got a positive exponent, right? Where did that base go? So it was in the numerator. Now the base is in the denominator, right? So in order to get a positive exponent, I need to move that base to the opposite side of the fraction.
See, that makes
1 over
everything
8 at the end.
complicated, though.
No, it'll be fine.
He said it would be fine. Okay, that was unnecessary.
So, right? That's going to be 1 over 7 to the third power. Right? You just move that base to the other side of the fraction. So negative 5 to the negative 2 power is going to be what?
1 over 5. Negative, well, 5 and 2.
1 over negative 5. The key here is when I'm looking at this, right? I need to look at each base individually. Okay? So when I say, so I'm going to highlight these bases. Okay, you guys really need to bring the attention up here. So when I say look at each base, right? 3 is a base, right? Each kind of individual term. So is there any 0 or negative exponent there
Yeah.
with the 3?
Okay.
No. So I'm just going to rewrite that, right? And then I look at the next base, so that s cubed. Do I have a 0 or negative exponent there? No. So I'm going to rewrite that, right? Because it's a positive exponent. So now I have t to the negative squared power, or negative 2 power, right? So do I have a problem there?
Yeah.
So what do I need to do with that t?
You need to put it on the bottom in a fraction.
On the bottom in a fraction, right? So I'm going to do this whole multiply by t squared, and we're going to kind of bring this together into a final answer. Okay, Ari, you need to be taking notes. John, taking notes. Okay. There's my last base. So z to the 0 power
It's a 0.
is going to be 1, right? So now I look, and I'm just going to combine this all as one thing, right? So that 3s cubed, right? I know I have a t squared, right? And then I'm just not going to write that times 1 because multiplying by 1 is just itself, right? So I don't need to multiply by 1. So there's my final answer. So I want you guys to take a second and try that second one. See if you can write that without any 0 or negative exponents. All right. So let's look at this. What's my first base that I got to look at here? The 4.
The 1. Okay.
Okay?
That's 1 time.
So that's 1, right? What's my second base? That x. What do I need to do with that one? So I need to flip it to the denominator, right? So I'd have 1 over x cubed. Numerator's the top. So that's where it's at.
I'm thinking about the final answer.
Oh, okay. And then what's my third base? That y. Do I need to do anything with the y? So because that is a positive exponent already, I'm just going to leave that as it is. Right? It's a positive exponent. It's not 0, so I'm good there. So now when I write this as kind of my final answer, right, y squared is what's left on top because I have that times 1, so that's not going to change anything. And then I have my x cubed on the bottom. Yep, because that's where it was, so I'm just going to leave it there. All right, last thing. She doesn't know what's so funny.
Oh, I do. I'm just not going to share it with you.
All right, so last thing. Evaluating these expressions. So these are just like evaluating expressions we've done all year, right? Where we plug in the values. But the first thing I want to do is I want to simplify it based on the exponents first, because that might make my life a little easier, right? So I'm going to simplify this, right? So look at my first base. Is there anything I need to do with that 3? No, right? Positive exponent, it's there, so I'm good.
The x and the 2 not negative.
So, yeah, so then I look at x squared. Anything I need to do with that one? Nope, so I'm going to leave that, right? X squared. What about y to the negative 1?
Negative.
So it's a negative, right? So it means it's going to go where? Denominator. So I'm going to skip a step from what we've been doing, right? And just write it there. So I could say y to the first. Right? And then what about the last one? Z to the 0.
That's times 1.
It's going to be 1. So do I need to write that in there at all? No. So now I can plug in the values, right? So I have 3 times, what's x going to be? 2. Right? So 3 times 2 squared over y. So now I look at order of operations, right? What comes first? Exponents. So 3 times 4 over 3. So what is 3 times 4? 12. Remember, fractions just mean divide, so 12 divided by 3 is 4.